Alright, so today we're going to be talking about binomial queues. Binomial queues are different from priority queues or heaps. They have the same function, delete max or delete min, but they are going to perform that function differently. So it's important to note that there is a difference, and you're going to need to figure out how to distinguish between the two. Because if you are just told to delete from do a delete min on a binomial queue, that'll be different than a delete min on a priority queue. So let's first just take a look at binomial queues. What are they in their basic form? Well, it's a way of just storing elements. So if we take a look at it, we can say that there's a 1, and the 1 is going to indicate that there's one node. We've got a 2, so there are 2 nodes. A 4 is going to look just like a 2, but it'll have another node coming off of the root with another pair of 2. And I'm sure you guessed it that an 8 will have the original 2 nodes, then a subset of those 2 nodes, and then off the root again, there'll be another subset with another subset, making a total of 8. So you got 1, 2, 3, 4, 5, 6, 7, and 8. So that is what it looks like in a nutshell. And let's get right to figuring out how to perform a delete min or delete max from priority queue. So this is a minimum priority queue because you'll note that the minimum is the root in all of these cases, even this case, because there's only one element. So all we could do is we take a look at all of the elements and we say, what is the minimum element? We know that we really only need to compare the roots. We know 7 is greater than 5 and 5 is greater than 1. So 1 is the smallest, obviously. And we just perform a delete min on it by erasing the 1. Now the problem is, this leaves us with a couple of floaters, these sort of hanging nodes that are right here. Now we can't leave them like that. So what we have to do is we have to restructure, reorganize. It turns out we have a 1, so we can pair the 1s together. If we didn't, it'd be fine as is, but since we have an extra 1 that it can go with, it has to go with it. So we put the 2 on top, because this is again a minimum priority queue. You would get marked down if you put the 2 on the bottom, or down here on the 7. And so we've got that. And next, we note that there's a 3, 4, and a 5, 6. So in order to add the 3, 4, 5, 6, all we have to do is merge them. Now we can merge these 2 together if we wanted, but we could merge these 2 together if we wanted. We could even merge these 2 together if we wanted. The important point is just that we can't have any dangling ones by itself when they can be combined. So I'm going to merge the 3, 4. Let me write the 3, 4 more like this. And I'm going to merge it with the 5, 6. It's important to note that the minimum value has to be on top. This would be a wrong way to merge it. This, however, is a good way to merge it. So you have 3, 4, 5, 6, and the 2, 7. Again, this is ordered from the lowest number of elements to the highest number of elements, just like in our example earlier. So that is the answer. That's how you delete a min from a priority queue. See if you can figure out this one. This one's a little bit more complicated. Maybe pause the video, give it a try. But I'm going to start, so here we go. We look, and actually in this one, I'm sorry, I should have said this before, but this is, you'll note, a max priority queue. So what we're going to have to do is find the max and delete the max from the max priority queue. Well, a lot of people will immediately jump to the largest and say, okay, let's delete 27. That's not true, actually, because there's actually a smaller one, a smaller sort of queue that has a larger number. So we're looking to delete the max number, so 37 is the number we're going to need to delete. So if we delete 37, that leaves us with a dangling 14, which means we're going to need to tack the 14 onto the 5, right like this. And again, this is a max priority queue, so the 14 goes on top. Then we've got a 13 and a 6. Now we can add these however we want, but I think what we're going to do is we're going to just add the 13 right like this. Perfect. So now note that every single value decreases. It doesn't matter that these ones don't decrease. These don't have to be less than each other, but all of the children have to be less than the parents. So that's sort of, again, important to note and distinguish. So that was a delete max. Let's see, this is a max priority queue, so let's see if we can perform a delete max on this max priority queue. I'm going to quickly resize it and make it a little smaller. That way we can work with it. Alright, so let's take a look. We've got, this is a max priority queue, so we look and we see it's not 15, it's actually 31 that we need to delete. If we had, like, let's say a 90 here, we'd just delete the 90 and it'd be done. But we don't have a 90, we have a 25, so that's what we're going to have to deal with. So we delete the 31 and the vectors or lines associated with it. Then we're going to have to merge the 17 and the 25 together. Then we can merge the 15 and 8 together. And finally, that means we're all set. We can't merge anything else, so we just make this look pretty, and then we're done. And that's the final answer. Let's see, we've got, I think, two more. Two more is quick examples. Let's see if we can work through them real fast. I'll again resize this just to make it a little easier to work with and see fully on the screen. This is a minimum priority queue, so we are going to perform a delete min. So the minimum is 5, so we delete it. We then take 17 and merge it with the 25. And looks like we have, oh, look at that. We've got the 17 and 25, which can merge with the 6 and the 8. So the 6 and the 8 merge, making sure that the 6 is the highest value. We can't put 17 as the highest. 6 has to be, because it's a minimum priority queue. However, we'll note that now we can still merge these two, because this is a 4 pair, and this is a pair of 4. So we can merge them, or we could have merged these ones if we wanted to. So let's take the 6, put it as root, and merge it just like that. So it's not overly pretty, but you guys get the point, I think. And that would be the final answer, right like that. If you want to be, sort of nitpicky, you can restructure it and make your higher queue go on this side, and your lower queue go on this side. But that is the final answer. And then last but not least, try this one out by yourself. Maybe pause the video, give it a shot. You can tell that it is a minimum priority queue because the minimum value is on top, or the lowest value is on the top of the queue. So, give it a shot, pause the video, try it yourself, and hopefully you've done that, because I'm going to start. Obviously 1 is the smallest value, so we delete 1 and everything associated with it. We merge the 5 with the 11. This is pretty familiar, I think. And we leave the 5 to be merged with the 2 and the 10. The 2 has to be the root, because 2 is smaller. And then we can merge however we want. I'm going to merge the 2 and the 3, just for variety. So, just like that. And that's the final answer. If you guys get a slightly different tree than me, it doesn't necessarily mean it's wrong. It just means you might have chosen a different path than I did. That's the beauty about this problem. There are multiple answers, which is awesome. So, thank you guys very much for watching. Hopefully you guys now understand binomial queues and how to delete a min or a max from them. Make sure you remember that they're different from a priority queue. So, thanks for watching. Bye.